take a look at significant figures, how to figure out the number of significant figures in a measurement, and also how to perform calculations and rounding to the correct number of significant figures. So whenever you look at a number, some digits in that number give us useful information about how accurate that measurement is. And other digits are really just placeholders. For instance, some zeros might be there to move a number into the hundredths place or the tenths place. So there are certain rules about what's significant. I'm going to go through these quickly because I'm about to teach you a shortcut where you can kind of bypass these rules and still figure out the significant figures. So any non-zero number is always significant. Non-zero means any not zero number, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I look at the number 82 grams, there's two significant figures there, 8 and 2. If I look at 32.9, there's 3 significant figures there. Zeros can sometimes be significant. Sometimes they have meaning in the number, and sometimes they're just holding a place value. Anytime a zero is between non-zero digits, it's significant. So for instance, 60.2 has 3 significant figures because that zero is sandwiched between the 6 and the 2. And the next number has 5. Zeros are also significant if they're at the end of a number when there is a decimal place present, a decimal point present. So for instance, 92.08000. That has a total of 7 significant figures. That 0 between the 2 and the 8 follows that second rule, sandwiched between 2 non-zeros, and these zeros are at the end of a number when a decimal place is present. 7.00 has 3 significant figures. Essentially what this is saying is I know something is 7 grams, and I know that all the way up to not just the tenths but the hundredths place. That's how accurate my measurement is. Okay, 200 would have 5. Zeros are not significant if they appear in front of non-zero digits. For example, 0.007, those zeros are just holding the 7 in the correct place. It's holding the 7 not in the tenths or the hundredths, but in the thousandths place. So those zeros are not significant. There's only one significant figure, and the next one has 3. Zeros appearing at the end of a number with no decimal point present are not significant. So for example, 2000 has no decimal point present. Those zeros at the end are not significant. There's only one significant figure, the 2. Notice the difference between if I intentionally put a decimal point there. This is telling me I know something is exactly 2000, and I know that up to the ones place. So this would have 4 significant figures. That first number, those zeros are really just there to keep the 2 in the thousands place. So these rules can be confusing and annoying to memorize. So there is a shortcut where you can bypass memorizing these. And the shortcut is like this. You look at a number. If the decimal point is present, you're going to start looking at that number from the Pacific side or the left side. PP, present Pacific. If the decimal point is absent, we're going to start looking at the number from the Atlantic side. AA, absent Atlantic. So let's look at an example. 0.0300. Is the decimal point absent or present? It's present. So we're going to start looking at this number from the Pacific side, or the left-hand side, and we're going to start moving through the number until I find the first non-zero. What does that mean? I'm going to rewrite the number here. So I'm going to start approaching this number from the left because the decimal point is present. Okay, here's my first number. It's a 0. Keep going. I want to move until I find my first non-zero. Here's my second digit. Oh, it's still a 0. Keep moving. Oh, there's my first non-zero digit approached from the left. Now, this number and everything after it, whether it's a 0 or not, is significant. So there's 1, 2, 3 significant figures. I'm only approaching it from the left because the decimal point's present Pacific. Let's look at another example, 500.0. Decimal point's present. We'll start looking from the left. Okay, I'm going to start from the left-hand side of the number and move till I find my first non-zero. Oh, the first digit is a non-zero. So that and everything after, whether significant or not, or whether 0 or not, is significant. So there's 4 sig figs. Here's another number, 6,200. There's no decimal point. Decimal point's absent. So we're going to start looking at the number, in this case, from the Atlantic, or the right-hand side. So I'm going to move to the right And then I'm going to move through the number again till I find my first non-zero. That and everything after will be significant. So starting from the end, okay? That's a 0, keep going, that's a 0. Oh, there's my first non-zero. That and everything after, whether 0 or not, is significant. So there's 2 sig figs. So it's the same process, it's just moving through the number in a different way, depending whether the decimal point's absent or present. Okay, this one, decimal point absent, we'll start from the right-hand side. Okay, there's a 0, keep going, there's my first non-zero. That and everything after is significant, so there's 3 sig figs. Here's some examples to try. You might want to pause the video, try them. Here are the answers. The first has 4, this has 1, this has 3, 4, 4, 5, 5, and 1. Okay, as a note, if you have a number in scientific notation is a way of writing a number so that you can group all the insignificant zeros in the exponent. So all I have to do is look at the coefficient when counting sig figs. There's 1, 2, 3, so there's 3 sig figs in this number. You can ignore the times 10 to the when counting sig figs. And in this last one, there are 4 sig figs. 1, 2, 3, 4. Okay? Now when you're doing calculations, there's certain rules you have to follow in order to make sure that you're rounding your answer correctly. So when you're doing multiplication and division, you want to make sure that your answer is rounded to the correct number of significant figures. So you want the same number of significant figures as the measurement with the fewest significant figures. This is the rule for both multiplication and division. So for instance, let's say I have these two numbers, 57.114 and 4.750. If you were to multiply them and put it in your calculator, this is what your calculator would spit out. Your calculator does not understand how accurate your number or result should be. But in chemistry, we need to make sure that we are not over-representing the accuracy of a number. So we can only have our answer rounded to as many significant figures that are in the fewest going into multiplication or division. So for the first number, there's 5 sig figs. In the second number, there's 4. So I want to round my answer to 4 sig figs, the fewest amount. So I want to keep the 2, the 7, the 1, and I'll keep one more decimal place, the 9 rounds that to 271.3. Let's look at another example. These two numbers are divided, and this is what your calculator would spit out. So how many sig figs should I keep? Well, the first number has 3 and the second has 2, so my answer should keep 2. So I want to round my answer to 3.3, which now has 2 sig figs. Let's look at another example. 111 has 3 sig figs. 4 has 1, so I want to round my answer to just 1 sig fig. How would I round 444 to just 1 sig fig? Well, I would want just one non-zero and then make the rest zeros. Let's keep the first number, so I'm keeping the hundreds place, and make the other 0. I'd round that to 400. If this were 464, say, it would round up to 500. That's the rule for multiplication and division. I am counting the sig figs and the numbers going into my calculation and rounding my answer to the fewest amount. Addition and subtraction has a slightly different rule, so make sure you memorize the difference. With addition and subtraction, my result should have the same number of decimal places as the measurement with the fewest decimal places. So I am counting the number of places after the decimal, and that's what my answer should have, the same as the fewest. So for example, 2.3 minus 0.567. This is subtraction, so I'm using this rule. It's a little different. I am not counting sig figs. I am counting the place after the decimal. So the first number has 1 place after the decimal. The second has 3. So I want my answer to have just 1 place after the decimal since it's the fewest. So this would round to 1.7. Let's look at another one. This is a combination of addition and subtraction. If I plugged it in my calculator, this is what I would get. What should I round my answer to? Well, I should round it to just 1 place after the decimal because this number has the fewest. So this would be 143.9. Let's look at one last example. Again, this is addition and subtraction, so I'm going to go by places after the decimal. Well, this number has no places after the decimal. It's a whole number. So I should round my answer to no places after the decimal, or a whole number. I should round it to 9. Okay, so when you're doing calculations, pay attention to whether it's multiplication or division. That you will count the fewest sig figs and round your answer to that amount. Or if it's addition and subtraction, in which case you will count the places after the decimal and round your answer to the fewest decimal places.